Good morning and welcome to Race Industry Now, the weekly webinar series from ePowerTrade, presented to you by ARP, Performance Plus Global Logistics, PIC, Ferrea Racing Components, and Fifth Third Bank Motorsports. I am Francisque Savignan, the founder and CEO of ePowerTrade, the racing industry, every minute, every day. This is episode 448, and we're going to be talking with Mike Copeland from Harrington Hydrogen. With me this morning are Judy Kinn, the co-founder of ePowerTrade, and wonderful host, Mr. Brad Gillie. Judy?
Thank you, Francisque, and thank you, everybody, for joining us today. My phone has been blowing up with texts. I've received emails this week from attendees joining us. So I'm really thrilled to have Mike Copeland on today. He's brilliant. And I just hope you guys learn and ask all the questions you want. So that's why we brought him on. So Brad?
Thank you, Judy, and thank you very much, Francisque. And I think Judy said it best, ask all the questions you want. Mike and I had a great conversation yesterday ahead of today, and I think this is going to be a pretty busy one, and we're going to have a lot of fun. So we'll see you, Judy and Francisque, coming up here shortly as we welcome on Mike Copeland, the CEO of Harrington Hydrogen. Today's topic, today's title, Performance and Racing Engines in a Carbon Neutral World. Is hydrogen the answer? And I would encourage anybody who has any questions, feel free to type it into the chat. We're going to get to as many as we can. But it's really interesting where we are, whether we call this a crossroads, an evolution, whatever it might be, as to what we're going to be racing in the future. And we've talked about a lot of different options, including electric, but I know a lot of us are gearheads and we want that internal combustion engine. And I really look forward to what Mike has to say. So Mike, welcome. I hope you're doing well today. Thank you very much.
Good morning. Yeah, I'm doing great.
All right, well, let's just get started and talk about hydrogen and some of the things that you're doing at Harrington Hydrogen, because I know you guys are pretty far down the road with all of this.
Yeah, we're in our coming up on our 5th year working with hydrogen, and we've learned so much and come so far. So it's ever changing, and the world is ever changing. The response and the number of people that are looking at hydrogen is just expanding rapidly.
Yeah, which is really neat. Well, let's first talk about this because, as I mentioned, you know, we're at an evolution in racing as to what we're going to be doing, what we're going to be racing in the future. So let's start by talking about, why does racing need to change? I mean, the fuel we use today works perfectly fine, right?
It does. Yeah, absolutely. The problem is that basically every racing series that exists, none of the vehicles have any emission components at all on them. So by definition, they're dirty. They create more hydrocarbons. They create more regular carbon. They you know, when you start tuning the engine for peak performance on gasoline or methanol or whatever you choose to use, depending on your series, the more power you make, the more fuel it takes, the more fuel you put in it, the dirtier it gets. And you know, I don't have to tell anybody that's in racing, if it came down from the legislators that now all of the vehicles that race have to meet the emission certification requirements for the model year or for the current year, it's a drastic, it basically would end most racing.
Yeah, and which is a scary thing for all of us to think about, because this is not just the business that we're in, this is the passion that we have. And I think that's a really big deal. I want to start, when we talked yesterday, you said something that kind of wowed me in a big way. And I think that's a good way to start talking about this as well. But you are working on several different engines and a lot of different things using hydrogen as the fuel. And we'll get into that. But the question I have for you first, Mike, is, after you've run these engines, after you've done a lot of testing and all of that, when you pull the heads off of them, and we're starting to talk about a carbon neutral world, what do these engines look like, and what does that do for longevity of other parts of the engine, including things that we have to use in them, like oil?
Well, you know, we've continually been running on the dynos for years now, and we can put a borescope down the cylinder, pull a spark plug out, put a borescope down the cylinder, and the engine looks like the day we bolted it together. If you don't allow any other form of fuel or anything that would burn into the combustion chamber on hydrogen, it's impossible to make carbon. There is absolutely no makeup in hydrogen, nothing in the makeup of hydrogen that will allow it to make carbon. So, we're testing oils as an example. And I have a partnership with Redline Oil, and they support everything we do. And they run all the oil analysis and tests for us and everything. And the oil never gets dirty. And when you test it, there's no carbon. So we're estimating that our oil life, as an example, will go to, for our street engines, probably 50,000 mile oil changes.
That's incredible. That is truly incredible. So I know a lot of people have several questions about this. We're going to talk for a minute. We're going to get to a lot of the questions on the chat that are starting to come in right now. So when we talk about alternative fuels, there are a lot of different things that are out there that are carbon neutral in various ways. So why hydrogen? What makes it work for you?
Well, hydrogen, if you go back, we didn't invent hydrogen, right? Others have done it in the past. It's been tried and then didn't get through and all of that. There's more raw element to make hydrogen in the world than anything else. As you know, it can be made from natural gas. That's what they call blue hydrogen. Gray hydrogen is done a traditional way. Green hydrogen is made with renewable energy. So it's an electrolysis process. And basically it's made from water. So H2O, pretty simple, take the O out and there's the hydrogen. So that's how it's done. A byproduct of making power electric with nuclear energy is hydrogen. So they make that and they blow it out the window because they don't have a use for it. So there's been a lot of discussion. I've talked to Westinghouse, as an example, makes what they call a micronuclear reactor. There are a number of universities in the country that get all of their campus power from a micronuclear reactor, and all of them manufacture hydrogen as well. So it's the most plentiful element. It truthfully is very stable from the standpoint of what you get when you make it. It's very consistent. It doesn't really require any other chemicals or anything else to be added to it. So the biggest issue has always been power, and I'm sure we're going to talk about that, but we've come a long way in that direction.
Yeah, we will definitely talk about power because people want to know about that. I know a lot of OEMs are doing things with hydrogen right now, and obviously they're continuing to develop what might be next. Whether it's BMW, Toyota has a large presence in this, including race cars that are actually out there right now. When you start to talk about you can get hydrogen from pretty much anywhere, and I'm not picking on electric, but a lot of people say, well, electric is a clean running car. But you have to make the electricity. You have to get the lithium for the batteries. You have to do all of these other things. In what you're saying, it sounds like to me that using hydrogen is a totally clean process from beginning to end. Is that fair to say?
If you use green hydrogen, green hydrogen is manufactured with renewable energy, and there is zero carbon footprint from doing that. We can take that green hydrogen, run it in our pickup truck, as an example, or any of our hydrogen vehicles. We extract the energy to create transportation, and we do it with zero carbon. So we're the only true, from manufacturer to use and extracting the energy for transportation, with zero carbon footprint.
That's incredible. All right. Well, you mentioned it. So let's talk about making power. And I know these are the things, solutions that you're coming up with now and using these in real world vehicles. So tell us what you're working on and what you've discovered.
All right. So I have 3 vehicles running on hydrogen right now. We have a few more programs in process that we're working on. The pickup truck was a 48 Chevy pickup truck. And if anybody searches Google for hydrogen truck or my name, you're going to see a lot of videos on that. We have one in particular that has over 1.8 million views. So we started the same way many have in the past. Analytically, we did all the research and all the testing on hydrogen and what it should produce. And frankly, the numbers are better than what anybody had produced, but still not to the level we needed. So in the past, there was a program done much like ours. We have a 6.2 liter LS with a Magnuson 2650 supercharger on it. they had run a program with a 6-liter with a supercharger on top of it. We're running at 9.3 pounds of boost. They ran at just over 25 pounds of boost. Their max power they made was 128 horsepower.
Ooh.
So analytically, when we ran all the data and all the numbers, it told us we would make approximately 267 horsepower. Our first dyno pull, and that was information that friends in the industry had shared with me. Our first round of dyno, we made 370 horsepower, and we've continued to refine it from there. And we're right at 500 horsepower with a truck, and that is an injector limited number. We're using experimental parts in all of these hydrogen vehicles that we have, because the production is just not there yet. It's getting close, but it's just not there. But in the case of our pickup truck, we're running 2 injectors per cylinder. They were designed for a small 4-cylinder type application. So they basically, we're running 16 of them, and we're out of injector at 500 horsepower. So we're flowing all that the injectors will support.
Okay, so and this does go to one of the questions that's going through in the chat right now about converting. So what we know about engine architecture, and you take that LS motor, how different is a gasoline powered, boosted LS motor versus the hydrogen power that you're talking about?
Well, when I started down the hydrogen path, I for people that don't know, I spent 26 years at GM, all in advanced vehicles. I mean, I was involved in so many of the programs throughout the GM's period when I was there. So I have a lot of background, and I have a lot of friends. And many of those friends, when we announced we were doing hydrogen, reached out, and they supplied what they had learned, because a lot of people have played with this through the years, a lot of the OEs, a lot of different companies, a lot of the engineering companies, and they basically, I created a list of like a dozen items that we were going to have, that we had to solve, and power was one of those, right? So one of the other things that everybody talked about was engine temperature. And because hydrogen contains approximately, it burns about 3 times as fast as gasoline. So it's very easy to get sky-high exhaust gas temperatures. So in that process, I didn't want to have an engine failure. And I have a racing background, and we build race engines every day. So we followed a path and built a heavy-duty, high-performance based engine. I mean, it's a 6.2, but it's got a forged crank. It's got from K1, it's got K1 rods. It's got Wiseco pistons. Wiseco worked with me, and we used a shorter rod so we can make a larger piston physically from size to get more heat transfer. We're using Total Seal rings, not the Total Seal version, but the standard version of Total Seal. We did piston oil squirters. We did a lot of things to worry about temperature so that we could control that. And we started working on calibrations and doing different things. At this point, our exhaust gas temperatures, we've developed to the point that we're within about 100 degrees F of gasoline. So what that says is that basically we didn't need any of that. Now, we might have blown it up in the middle if well, we were alerted, but at this point, we have one engine running that's bone stock as the factory delivered it. That's a Gen 3 Coyote 5-point liter from a Ford Mustang GT. So we are to the point that we don't believe we're going to have to modify anything internal in engines to convert them to hydrogen.
And is most of what does change, is that all on the intake side? I mean, you talk about multiple injectors. I mean, are we looking at new fuel rails, new head designs, different things like that?
There is opportunity with cylinder head design to pick up power. I mean, we're not focused at that right now because, I'm looking at, from our perspective right now, a retrofit program where we can take an existing group of engines or existing group of cars and convert them to run on hydrogen. The Toyota, Ford, GM, BMW, Hyundai, they're all working at hydrogen as well. And as part of that, they're focused at their new vehicle programs, and that's perfect. That's where they need to focus. In the US, there are 292 million registered internal combustion vehicles. we can't throw 292 million cars away, and trucks and everything else. So our focus is to offer retrofit programs, and that we'll be able to retrofit those, convert them to run on hydrogen, whether it's gas or diesel based right now. So that's the direction we're going.
That's incredible. And I like that you say gas or diesel. I'm going to be pulling from some of the questions here as they're coming through the chat, and I'm probably going to go a little bit out of order as to when people are sending them in, but I think this is a good way to cover a lot of things. You threw out a number yesterday that really impressed me, and it came to octane rating. So the question is, is there a rating for hydrogen that's similar to octane?
Well, hydrogen, there's not a clear path to octane. Okay, there's not just a formula that you can use. If you make a couple simple assumptions, hydrogen comes in at about 130 octane. So we have the ability to really turn the power up, crank the compression up to take advantage of it. I'm working on a program right now where we're getting ready to convert a large number, 12,000 engines. And that engine is 17-to-1 compression with a turbocharger. And we don't expect to have any issues with detonation or any issues associated. All the testing we've done, and we've done some pretty crazy stuff, that fits right within our window, and we believe it's going to be something we can just use as is.
Wow, that is incredible. All right, so we're talking about racing applications as well. So in this context, and we're talking about fuel storage, fueling a car, safety, all of those things. So what can you tell us about that side of it before it even hits the engine?
Well, we use hydrogen. Hydrogen's basically used at 3 different levels, okay, from a pressure standpoint. And it is a pressurized gas that we're using. We are not using liquid hydrogen. Liquid hydrogen is an opportunity. It has to be stored at an extremely cold temperature to keep it liquid. The advantage is that it lets you get a lot more volume in a smaller tank. But, BMW did some work with that in the past, about 12 years ago. And if they just let the car sit, in basically 2 weeks, it would use a tank of hydrogen to keep itself cold. So it was always using up the hydrogen. But hydrogen's used in 3 main levels in a gaseous state: 350 bar, which is roughly 5,000 psi; 700 bar, which is just over 10,000 psi; and it's used at 1,000 bar. Although I don't know anybody currently that's using 1,000 bar. Most of the fuel cell vehicles that exist, the hydrogen fuel cell buses and lift trucks, high-lows, all of those things, they typically run at 350 bar. It's the most common. So that's where we set the truck up to run. If you go to 700 bar, like the Toyota fuel cell car that they offer and the Hyundai fuel cell car, they run at 700 bar. So it's the same process, different tank, different lines, and different regulator. And then we regulate down before it goes in the engine. So it would be the same basic process to go to that. The advantage to 700 bar is it gives you 1.7 times the volume in the same size tank.
Okay. And as far as tank safety, because that, again, we're racing, we're running into each other, a lot of things are happening. What can you tell us about that?
So the most common tank that's available today, and the tank that's in my truck and in some of the other vehicles we built, they're a cylinder shaped. They're spun aluminum, wrapped in carbon fiber. That's a level 3 tank, and they make a level 4 tank that is exactly the same, with a rubber bladder inside it. And that rubber bladder's purpose is to, should the tank be crushed or whatever, it provides another level of safety. Both level 3 and level 4 tanks are DOT certified. So that makes them legal to use on the road. If you see like a hydrogen bus as an example, they mount the tanks on the roof of those. And that's the same style tanks, like a big cylinder. I'm working with a company that's developed a new hydrogen storage tank, and they call it formable. And what that really is it's a series of cylinders that basically run back and forth almost like a big snake. And they're a composite. They're flexible. They're wrapped with a cloth, and then they're inside a steel tank. So if the tank were to be deformed or whatever it is, that allows an way additional levels of safety. So those designs either have been or very soon going to be submitted to the FIA for certification. So I had one of those tanks. Actually, we exposed it without the steel case around it in the monster truck that we debuted at SEMA this year.
I love that, by the way, monster truck running on hydrogen. That and the power that you're making with the monster truck and the potential there. What can you tell us about that?
Well, we have a target with the monster truck, and that target is 1,500 horsepower. It's a 540 cubic inch Chevy Dart based comp cam, and it has a Pro Charger supercharger on it. We did a really early run on it, and we were able to make like 1,000 horsepower with it without getting very far into the development. We're working on that right now, but we're turning the power up. And as I said, our target's 1,500. That's about where most of the monster trucks run on methanol. That's about the power level they make. The real advantage is there's no carbon. So because they run so many indoor stadiums, it keeps, they have issues with that, right? Even like we go to Ford Field here and go to the Monster Jam events, and a friend of mine, actually, whose truck we built is Paul Jensen, Team Throttle Monster, and they compete in that series and do exceptionally well. But they have to run. When we actually are racing, they open all of the outside service doors on the stadium, and we go in like January. So it's in Michigan, it's 0 degrees, and all the doors are open. But they have to do that to keep the carbon monoxide so that it can exit and then keep fresh air coming in. Fire marshals monitor the carbon monoxide all the time, and all of those happen that way.
Yeah, that which is a great thing. And think about how many indoor racing events that we have during the winter that are so popular, whether it's the Chili Bowl to up in St. Louis or in Indiana. That's a pretty amazing thing. So getting back to the fuel side of things, right now, if I go to a gas station or if we're in a racing series, we're dumping gasoline in, and it's pretty simple and standard. If I have an electric car, well, if we're racing, we're not even doing a pit stop. We're just moving the driver from one car to another. But if I'm in my passenger car, any number of pigtails might work at whichever charging station that I choose to park. How does hydrogen work when it comes to fueling the car and the availability of that to be able to find it in the marketplace?
Well, right now, availability is very limited. California has roughly 75 to 80 public hydrogen filling stations. That number is on a path to expand. They're adding more all the time. They just opened their first trucking center in California that's for hydrogen. So that's a pretty big deal there. Hydrogen is coming. The infrastructure bill had $7 billion defined to build 8 to 10 hydrogen manufacturing centers across the country. They have been assigned now. The states have been identified where they're going, and they're going to build those. They expect to have some of those online in 2026. So hydrogen availability is coming across the country, and it's coming really, really fast. They're now going to bump that number to 12 centers. There are a number of private companies that are entering Air Liquide or Air Gas in the U.S. They are working at that. They're looking at opportunities to do that. I've had a number of companies reach out to me. There's some new technology coming that's for manufacturing hydrogen, and those companies will be putting in centers that sell hydrogen and do it. They're also looking at lowering the cost of it. Today, I buy hydrogen at the Michigan Alternative Fueling Center, and I pay about $27 a kilogram. Kilograms equal, round numbers, roughly about 5 gallons of gas. Okay. So part of the infrastructure bill, their goal was to lower the cost of hydrogen by 80%. So if that truly happens, hydrogen will come in before taxes get added to it. It basically, if you correlate it to the gas, about $1 a gallon. So gives a lot of opportunity. Some of the people that I'm working with, one particular group who I won't share any of their details because I have an NDA, but they have a new technology, and their goal is to sell hydrogen extremely cheap. And they're working at putting centers in defining where they're going to go right now, and they're in negotiation with a lot of different states and a lot of different locations. So as far as filling it, the truck has a 3-kilogram tank in it. So roughly 15 gallons by kind of gas standards. That in the truck, it takes about 5 minutes to fill it. You pull up the pump, there's like a big air connect, and it's an industry standard. So everybody uses the same one for 350 bar. They have a separate one for 700 bar, so you don't accidentally hook the wrong one up. 350 bar, you connect it, it snaps on, you rotate a handle a half a turn, and you hit the button on the pump. It does a quick check, a pressure check to verify that there's not leaks. And as soon as it runs that check, which takes less than 15 seconds, then it will go into fill mode and it will fill the tank. It monitors temperature. And so because as you pressurize it to force it into the tank, the temperature climbs. So it monitors temperature, and if the temperature gets so high, it stops filling, waits a short period of time, and then it'll go back to filling. At 700 bar, one of the differences there is different connector, and the vehicle communicates with the pump via CAN. It talks to the pump, so it transmits what the temperature is in the tank. And they go through a cooling process halfway through filling the tank, and then goes back to filling it. So that's the main difference. It's really simple. I have a short video that's out that we did on filling my truck and kind of show the process and what we do. But it's really simple. And if you can put a gas nozzle in a car, you can use a hydrogen nozzle.
And I think that is obviously we talk about range anxiety. Part of that is availability when it comes to electric and hydrogen, but you talk about the infrastructure growing on something like that. The other part of it is, you could go to a 20 pump gas station now and not find an available pump. If we're all charging our electric cars for 20 or 30 minutes at a time, that even changes that a lot more. This sounds like a much more reasonable compromise in something like that. What do you see the forecast being, Mike, on something like this, to where we do have a little more infrastructure? And which, by the way, let me also ask in that question, when you're talking about filling up that tank, how far can I go on a full tank, the similar size as yours?
Actually, it kind of just like gasoline. The harder you run it, the more it uses. And our truck is, like I say, 500 horsepower. We have a Tremec 5-speed in it. I'm a hot rodder, right? So I kind of enjoy it. If I force myself to not, hot rod the truck, it's 200 to 250 miles roughly on range. A lot of people question that number. And here's what I'll tell you. I said I was going to talk a little bit of technical in this and share a little information. Hydrogen, while it's a fuel and the engine consumes it just like it does gasoline, you simply cannot use gasoline metrics, gasoline assumptions, and apply it to hydrogen. It is completely different. And, some of the simplest things are, gasoline optimum fuel mixture for gasoline is 14.7 to 1. So 14.7 parts of air to 1 part, or fuel to 1 part of air, right? Sorry, I got that backwards. But anyway, we've run our fuel mixtures as lean as 100 to 1 on hydrogen.
Wow.
Right? Now, that's not where we get our best performance, but we could. We've also identified that we can control engine temperature based on fuel mixture. So we've run 20-minute run cycles with 0 cooling fan on our truck and seen a maximum temperature of 152 F. Now I can also change the fuel mixture and heat it up fast. So that's an opportunity as we start looking at going towards production to get a car up to temperature quick on a cold start morning. As far as cold start, there's no fuel enrichment required with hydrogen for cold start. We run the exact same fuel mixtures at 0 degrees that we do 0 F as we do at 100 F. So we've had extremely successful lessons that we've learned in hydrogen. There are many other things that simply, there's a lot of people on the internet that claim they know everything and talk all about it. If they knew what I know, they would know that their information and what they're making their assumptions from is wrong.
Yeah, and again, a lot of real world stuff. A couple of questions here from the chat. Are hydrogen storage tanks much larger and heavier than gas/diesel tanks? And I'm assuming that means on the vehicle. So if I'm building a race vehicle, or, I'm sure a lot of people are interested in the personal side of it as well. How does that compare as far as the weight of a tank?
So the 3 kilogram tank I use in the truck, all in, is about, including the straps that hold it in. And I have it mounted in the bed because it's a cylinder and I want to show it off. Interestingly enough, if I put you in the truck, or if you got in it and went for a drive and you didn't know it was hydrogen, you would not know. It sounds just like it's on gasoline. It drives just like it's on gasoline. It doesn't do anything different. So, but that tank that's in my truck weighs just over 100 pounds empty. Full, it weighs about 110 pounds. So remember, we're running gas. So it's not like, 6.5 pounds per gallon for gasoline. So that's about where the weight is. So
So
basically
if I
a
had a
15
20-gallon
gallon
gas tank, what's gasoline? About 6 pounds per gallon?
Yeah, roughly just over. Yeah.
So then we're talking about 120, 140 pounds for a full tank of gas, which sounds like that's comparable.
Yep, it is.
Okay. This is a question more about you, Mike, and where we're going with Arrington Hydrogen. Are you looking to only provide components and engineering expertise, or is it your plan to develop this as a specific business? If so, might there be franchise opportunities? So where are you with the business side of this?
Our goal is to do both, basically, in some specific area. There's 8 verticals that hydrogen fits in, okay, that we've identified, 8 opportunities, and we put a number of the different opportunities in each category, right? I started out focused at, as I said, I'm a car guy, right? Have been since I was a little guy out in the garage working with my dad. I was like 5 years old with my hand up in the door of a 54 Ford to hold a nut so my dad could put a window regular, right? I've been that way my entire life. I love the performance industry. Frankly, the performance industry is not where the money's at, right? Every time you have to develop a specific calibration for a different engine, it's a lot of time and a lot of money. So if you can fire up the cookie maker, and you can do the one program that we're working on right now is 12,000 of the exact same engine. I have another company reach out to me that has 5,700 non-road vehicles that they want converted, right? That's 5,700 exactly the same. So you do the calibration work, you develop everything, and then you turn the cookie maker on. So, but in my case, I love the performance industry. I'm a part of it. I want to be a part of it. I think I told you yesterday, when my wife and I agreed to invest our own money and go down this path, it was because we have 20 cars of our own, and we have a 6-year-old grandson, and we want him to be able to drive our hot rods when he turns 16. The way everything's changing in the world, I'm not sure that's going to happen. People could say that we're wrong and it won't happen. Most people don't know that Australia has made a decision by 2026. Their goal is to eliminate fossil fuels. That's coming across the world. Other countries are ahead of them, some aren't. So, but as far as franchises, as we get into this, as we grow the business, we're going to offer conversion packages. And we're going to look for companies around the country that have the skill set, that have the dedication, the work ethic, all of those things to be a part. And yes, we're going to look. If we sell a package or a number of packages into wherever it is, Indiana or Colorado, or all of these states, California, everywhere, it doesn't make sense to ship all those cars to Michigan, and it doesn't make sense for us to go through. We just physically couldn't do them all anyway. So yes, we're going to be looking for what I'll call partner companies that would be trained in how to do what we do, and then we would sell them the packages, and then they would install them.
Okay. And as far as then that future goes, and not to get political here at all, like just literally asking real questions. I mean, at one point it looked like, hey, we're at a crossroads. If a government's telling us we need to be all electric or something like that, well, then you have OEMs saying, well, maybe that's only going to be about 33% of the market. And you have, car dealers like in the world where I live in NASCAR, Rick Hendrick's a big car dealer saying, look, the consumer is going to decide what we do and where we go with something like that. Where are we, or what can you tell us where we are, maybe with things like legislation, things that are going to help with this infrastructure, the openness to explore alternative fuels like what we're talking about here with the carbon neutral product like hydrogen? What can you tell us?
Well, I think it's best if I describe it this way. Okay. My wife asks me continually, how come when they talk on TV all the time, all they talk about is electric vehicles? Okay. And my answer has been the same since we started. Now we're working really hard to try and get the word out, to promote, to do all of those things of what we have. I did Forbes last week, right? So that's helping get the word out. I have another one next week. So, but the reality of it is, today electric vehicles exist and fuel cell vehicles exist. Hydrogen ICE. Now, Toyota's done a good job with what they're doing, and they're talking about it. BMW talks about it a little bit. They were probably the first to really push it out there, like I say, about 12 years ago. GM did a lot of work in it. Ford did a lot of work in it 10, 12 years ago. But until we did it, until we started promoting what we've done, you couldn't really say that it has been done. Now, we're a small company in Michigan, okay? I mean, I have two companies here, Arrington, and then we own a company, Diversified Creations. We're still small potatoes, right? We're a mom and pop shop. So we have done things and shown things. We took the truck and went to Roush Industries. They have a state-of-the-art emission test lab there, and we ran the EPA tests on the truck. We ran FTP 74, FTP 75, and USO 6, which are the three most common tests that you run in the when you're doing emission testing. Out of those tests, we proved that our truck makes 0 carbon. It's a minuscule number, but we actually clean the air a little bit from the carbon that's in the air. I mean, we do a bag test where you collect all everything that comes out of the truck. And as I said, Roush is an expert at this. Their testing and their facility is certified by the EPA. It's certified by CARB. They accept the data from that facility. Our NOx level, now NOx is something that varies a lot depending on where you're at. Typical NOx levels are in the 4 to 4 point whatever. There's some that are a lot lower. There's some that are a lot higher. Currently with 0 exhaust after treatment. So now we have headers, stainless exhaust, and a pair of mufflers in the truck. Our NOx, and this has always been a problem with hydrogen, because NOx is a byproduct of high temperature burn. So typically the higher your temperature, the more NOx you create, and it can get exceptionally high. Our recorded NOx level, highest recorded NOx level, happened at 2 points during the USO 6 test. And that's wide open throttle uphill for extended periods of time. And our highest recorded level is 0.083. Now, analytically, we've developed a process that we're going to go back and test. Now, we believe with just some more tuning, we can get to approximately 0.05 with some more tuning and some more opportunities, maybe a little better. Analytically, we have a new system that we're going to test. It will take us to 0.014. So when you go into the world, and that's the only thing we output, right? Mm-hmm. There's no carbon. There's no anything else. That's all we have. The truck engine started in a 2014 Cadillac CTS-V. That's basically what it is, a 6.2 with a supercharger. That engine certified in 2014, and they define, it's called a BIN, B-I-N. That engine certified at a BIN 150, 150. As you go, now it's not linear, lower numbers are always better. So the lower number you can get to, the difference between BIN 150 and BIN 125 could be a 35% reduction in emissions. A 2024 Corvette certified at BIN 125. Okay. Our truck today with 0 exhaust after treatment would certify at BIN 70.
Wow.
Once you get to BIN 50, it switches to what they call SULEV, super low emissions. With that, if our system that we're going to install works as intended, and as analytics say it will, we will be able to certify as SULEV 20 to potentially SULEV 10 with a 500 horsepower high performance engine.
That's incredible. That really is. And there were a couple of questions about NOx in there, so I'm glad you addressed them. I was going to get to those. A couple of racing questions here. And this is more of a comment, and I don't disagree. I think the racing sanctioning bodies should lead the way and run on hydrogen. NASCAR, Indy, F1, etc. Lead by example. We talk about Toyota is already going down that path. I know NASCAR has been to Japan to visit a lot of that. A question here. What worries me is the Garage 56 Le Mans hydrogen project has been postponed for 2 years because crash test is not for the fainted. Race car engineering wrote some time ago. So I think this is more about, again, goes back to the safety side of it. And we're talking about pressurized tanks and all of that. In the racing world, again, could you tell us where we are with that?
Well, there's no question that's a concern as you go into racing. A couple other concerns too, but that's the major one, right? Because it has to be safe. So the tanks that exist today, the cylinder style tanks, I believe that they could be updated and changed a little bit, and you could literally destroy the entire car and bounce that tank down the track, and it would still be fine, right? We have valves, safety valves on each end of the tank. They're designed for pressure and temperature. We electronically control the one valve, so we turn it on with the ECM to let the vehicle work. If that tank were to come loose, that wire would come loose, and when it did, that valve would close. So then the tank becomes a sealed. So they're intended, they have safety valves that goes over pressure, but otherwise you'd have to knock the valve right off of it. Interesting thing about hydrogen, it's the lightest element known to man. So if I release hydrogen, it's going to go straight up as fast as it can travel. We did a test where we created a hydrogen leak and we actually lit it on fire. The hydrogen goes up so fast and mixes with the atmosphere, it puts itself out. It exhausts the energy. Now remember, it burns 3 times as fast, approximately, as gasoline. So the fuel is exhausted and burned up a much quicker rate. Okay. And I may as well cover this because the number one question I get all the time is about the Hindenburg, right? Oh my God, you got an H-bomb. Oh my God, it's going to this, it's going to that. There are very few pictures of the Hindenburg accident, but the ones that are, if you look at them, the fire that created went straight up. None of it went down, right? Now, I always tell people, imagine if it had been gasoline, and that gasoline's heavier than air, and it went down and coated everyone and everything underneath it. Plus, it's going to burn 3 times as long. The people that passed in the Hindenburg accident passed from the crash. They weren't burned up. So that's one of the points. The other is the Hindenburg used a cloth balloon that they filled with hydrogen. Because hydrogen is the smallest molecular structure known to man, it'll escape through places that nothing else will. Now, they realized that pretty quick when they tried to put it in a cloth bag. So that bag actually had 7 different chemicals that were put on it to seal it. And then it was coated with aluminum, which is how it became conductive that let the power line burn a hole through it anyway. So that's it. The other side, going back to your original question, this tank I talked about that's formable and the process that it's created in, it would be much, much, much more safer from a crash perspective because it can distort and it can flex, and it's almost impossible to damage it.
That's a big thing right there. I know we're getting limited on time. I did want to ask the cost question because that's come up as well. And I know you talked about your grandson, but if we were taking our race car, vehicle, whatever, what would the cost be? Or in today's world, where we are in development, what are we looking at?
So the cost is changing rapidly, right? I'll give you an example. The first 16 fuel injectors I bought that are in the truck were $26,000 a piece. They're experimental parts. They're kind of one-off-ish. So if you want to play, you got to feed the piper, right?
Mm-hmm.
Today I buy fuel injectors for roughly $400 a piece, and they're still not production. That price will go down and down. The first fuel regulator I bought, I paid $5,000 for. Today I pay $500, right? So it'll get exponentially cheaper. I don't know exactly where we'll end up. It'll be by volume, and how many we can do. As I said, the calibration is very labor intensive, but every project that we do, every engine that we run on hydrogen, it gets cheaper, right? Because we create a bigger file that we can pull data from. We can compare, tune in as an example, the engine we're building this year for SEMA will be much easier than it was when we did the truck, because we'll be able to take a lot of the data from the truck, apply it. We'll actually be able to start it up on the same data as we used in the truck, and then we'll adjust accordingly, right? Because it is a different engine family.
Wow, that's really neat. I think another key thing, and all of the things that you talked about hydrogen that have been peppered throughout the conversation that really speaks to racers and people who want the internal combustion engine to live on, were some of the names that you mentioned. Comp cams, total seal piston rings, Wiseco pistons. You talk about literally parts we're using today. These are the parts that are on the engines that you're converting. So now we're just talking about an alternative fuel and the way to deliver that to continue to do what we love. So I think that's music to a lot of people's ears, Mike. And this really was an incredible conversation.
Well, thank you. So I was at PRI a couple of years ago, and we were having a conversation about hydrogen, and we were going through all those discussions. And it's my belief that if our system doesn't work, or if somebody smarter than me doesn't come up with something better, 75% of the companies that were at PRI will not exist in 10 years. Right?
Yeah,
Electric vehicles don't use oil. They don't use pistons. They don't use crankshafts. They don't use camshafts. They don't use clutches. They don't use most of them have a differential, but of some kind, but not necessarily the same as what we have today. When you do full, electric engines, electric motors, God, no electric engine. Anyway, when they do electric motors, they just drive the wheels. So all of those companies, there's no use for them.
Yeah, that's a big statement and a great way to end this. Mike, we hope to have you back. This truly was enlightening, and really enjoyed it today. Thank you so much.
Okay, I appreciate it. If I could just say one more thing, besides thank you to all of you. If anybody, I know there's going to be a ton of questions and a lot of things. My email is mike@arringtonperformance.com. Email them to me, and when I get time, I'll answer them. And I'm a racer. I'm a hot rodder. I live in this world. I love this world. And if there's anything we can do that lets us have it carry on for the next generation, we're all about it.
Thank you, sir. Thank you very much. a great session. This webinar has been recorded. It will be posted later on the ePartrade platform, distributed through our newsletter and our social media channels. For more information, please visit www.epartrade.com. We will be back next Wednesday. We're going to be talking safety with ESI equipment. Again, thank you very much and see you soon. Bye-bye.
ePartrade is a digital platform that we've created basically to make life easier in the business community of auto racing.
ePartrade, there is no e-commerce. It's literally a connection just like at a trade show. So now, any time of the year, a buyer could reach out to a supplier.
When you see a product that you're interested in, all you need to do is click on request more information, and then from there, it is forwarded directly to the buyer or to the supplier.
ePartrade really eliminates having to travel, closing down your shop. Now you have a place to showcase globally your racing product and technology.
Land speed record holder George Poteet's Speed Demon rocketed 481 miles per hour at the Bonneville Salt Flats. You don't go that fast without ARP fasteners.
There is no way that we could go the speed that we've gone, the number of times we've gone, with a lesser quality bolt than ARP supplies to us. And we absolutely wouldn't be where we were today if it weren't for ARP.
When failure is not an option, it's ARP-bolts.com.
We're Performance Plus Global Logistics. Our team of dedicated performance industry and logistics experts get valuable cars and components to the track on time in top condition. We provide expedited logistics solutions for the performance industry using direct routes instead of deferred options, and communicate all necessary information to the appropriate resources to meet regulations and ensure a smooth transit and secure delivery, both domestically and internationally. And we exceed customer expectations by providing best-in-class service with an efficient and cost-effective system in place. Contact us today to book your next shipment.
You work as hard as your truck, and you have no time for downtime. That's why more truck owners trust Blue Def, America's #1 diesel exhaust fluid brand. Each batch is guaranteed pure, so you can avoid costly repairs caused by inferior DEF. Demand America's best for your truck. Blue Def and Blue Def Platinum. Put trust in your truck.
Where will you find Ferrea racing components? Circle track, drag racing, and any top race shop. In every form of motorsports competition, our valves and valve train components deliver race-proven design and technology. And we've brought that same performance to our street applications as well. We're backed by 5 decades of experience, an extensive range of off-the-shelf components, and our custom valve department has the fastest turnaround times in the industry. Ferrea Racing Components. Stand with us or race against us.
Scriber Plastics has provided professional strength shipping containers to the automotive and performance industry for over 40 years. We have containers that will fit most any configuration of complete or partial engines and transmissions. Today we highlight part number 5148 cylinder head shipping and storage container. Base has double-walled durable construction featuring a cinch strap with an abrasion sleeve that securely fits your small block, big block, and pro stock heads to the base at all times. Talk to your dealers and distributors about the shipping storage container for cylinder heads from Scriber Plastics, part number 5148.